Hey guys, how's it going? So in the last stream, we continued working on the spline collision and also chaining splines together. So if I debug and show the splines, so we got it to a point where it'll make a continuous spline when we keep making sections like this, like so. And also the collision detection, that was my word, is now working reasonably well. So the next thing I'd like to tackle is, let's say I have something like this and it loops around. Because it's the same spline, it's not going to do the collision on itself. So there's two parts to what I want to get done. The first part is I want to do this collision detection on the self. So I want segments to be able to tell when they're overlapping themselves. Then, for both of that situation and where these junctions are found, we also want to split the segments there as well. Essentially what we want is individual segments for each actual section of network. And then that will help us make the junctions, and it will also help with parking, because each section will have a start and end point, which we'll be able to use for pathfinding. There's quite a lot to it. So what I'm going to try and do today is just get the spline detection. If I can get that done, great, and then I'm still trying to wrap my head around how the segment splitting is going to work. The way the detection is going to work, so we're going to basically iterate through each pair of control points on the spline, and then for each pair of control points we'll loop through all the other pairs of control points on the spline. So for example, here we'll have x1 and x2, or whatever, i1 and i2, and then on the other iteration it'll be like y or j1, j2. And the plan is to do a line detection between those 2 points, and if those 2 lines collide with each other, that will give us a point where they overlap. It won't be super accurate because obviously it's going to be a curve, and the line detection is going to do a straight line between those points, but it should be close enough where it's a good enough approximation. If we want it to be a bit more accurate later, we can take that location and find the nearest point on the curve, and we can do it that way instead. So I'll cross that bridge later on. And what I'd like to at least get to today is getting this detection set up, and at least just showing like a debug point or a debug sphere when these overlaps are detected. So if I can do that, that'd be great. The entry point for this is going to be when we update the network, and we take a look at the network item. So at the moment we create the new spline with the target data. That's the points where the players clicked. We then check if there's any current segments that we can append it to for when we're making those chains of splines. And at the moment it's returning that segment once it's appended it, or we're creating a new segment. So what we need to do is, instead of returning straight away, we need to run the detection after that point. So once it's either updated a segment or created a new one, we need to run that self-hit detection after that. What this probably also means is that at the moment, this is currently just returning a single segment, and the network manager is doing junction detection on that single segment. What we probably want is that to be returning an array of segments and then doing any junction detection on the array of segments afterwards. And that may also change as well. So that's probably one of the first things I could probably update, is just update this method definition to change it to an array, just to set that up. And we also want to change how this is handled, because it returns as soon as it's either updated or created a new segment, which means this will need to be put into like an if-else statement. Because at the moment it just returns, so it doesn't have to be in an if-else statement at the moment. So we'll have to change that. And instead of returning that single segment, we'll have an array of changed or created segments, which will return. Yeah, so I'll start with that. And I've already backed up the project as well, so the source code is all good. Close that for now, don't need that. And it will mean we'll get some errors to begin with here. Yeah, we'll have to make some changes to this here. So we'll have to change this to be an array of updated segments. Change that, and then we'll kind of loop through. And that will kind of be the same, but it will be in a loop of updated segments. So that will change a little bit. Yeah, I've been setting up some empty methods. So that's what that is there. So this update network, what I might do, just for now, actually no, we won't be able to do that. So let me just copy this, and we'll just comment that out. So this will be TArray of so it's an array of segments we're going to be returning. Okay. And we need to change the definition. Here. Alrighty. So what do we need? We can just create this. We can call this updated segments. We can do that. Okey-dokey, and we can also return this. Okay. So now instead of returning, could do is put this in a method which returns true or false. No, for now we'll just do this. So ball be appended to segment. So we'll do. So if it did append, we'll do be appended to segment equals true. And we want to update segments dot add network segment. So we're going through all the segments. We're attempting to append to it. If we do append to it, we add it to. We go ahead and append it, and then we add that to updated segments. Because it's done that, we check if it was appended to a segment, and if not, then we'll create a new segment. And then add new segment. And then just so we can compile this, we need to update the network manager. Just copy that. Oh, no. That should be fine. We'll change this to if updated segments dot empty. No, that's not what we want. So less than or equal to 0. Return. And that generally would mean it's an error because we should have either updated a segment or added a new one. There shouldn't just be nothing. And then this is going to be a loop instead. And for now, that should bring us back to where we were before. So I'll just check that that's still running correctly. Build, show splines. Okay. So that's currently still working, and let's just make sure the pendant is still working. Yep. Cool. Alright, sweet. So that's kind of how it is. Now the question is, who is going to call? Probably the network item. So we go network item. So this is where we either append or create the new segment. So it might be worthwhile doing the self-hit detection here. Okay, let's do that. This should actually be a normal point. Never mind. Ignore that. So now what we need is to create the method definition on the segment. It's going to be here. So later on we'll want to know when it comes to actually dissecting the segment, we'll want something with the information. I'll keep the method empty for now, and the name is okay for now, but I might change that later. done. Righty. Let's just make sure that method's being called, which it should be. So we're seeing the does hit self message showing up in the output log down here. That's fine. Alrighty. Now for the tricky bit. However, I have already in the utilities created this helper method. So it basically takes two lines and gives us an intersection location. So we've been making use of that. And so we have our segment spline. So that's what we're going to be looping over. And just show you that again. So we're going to be iterating over the pairs of control points and doing a line intersection between each of those pairs. Alright, so get the number of control points on this line, because that's going to be the number of iterations that we're going to need to do. So iterate over each pair of control points. Iterate over each other pair of control points. Line intersect the line between the two pairs of control points. That's not right. Make a line for each pair of control points. And line intersect for the two lines. True if lines intersect. Draw debug sphere if intersect found at the location. Alrighty. So the first bit should be reasonably easy. Int 32 non-control points equals segment spline. Get num of spline points. Yeah. Okay. Then we should check if control points less than 4. entirely necessary, I don't think, but never mind. Okay, so then the first 32 I equals 0. I less than num control points so it's 0 based index, so I want -1, and because we're doing pairs we want -2. Num control points plus plus. Oops. Okay. So for 32 j equals 0, j less than num control points -2. Then we just want to make sure that I doesn't equal j. So continue that. Alright, so we now need to get location of control point I and I plus 1. Get the location of control point j and j plus 1. Create a line. Okay, and then run intersection. P1. Get location at spline point. So I e spline coordinate space world. I plus 1 e spline world. Okay, and that F-line line equals alright, so we're making a line out of those. Then do the same with the inner line. line, inner line, inner line start, inner line end. Okie dokie. So now we should be able to use this now. So we need an intersection location. Radius, segment 6, color, let's do blue, yeah, sure. Okie dokie. And we can also do this. Cool. Okay, so hopefully what should see is a blue sphere when we have a segment overlap itself. Well, that's kind of clunky. I wonder why that's so slow as well. Yeah, it's really freezing up in between each go. It's not liking that method. Let me just check if it's the line intersect method that's causing that. Is this actually doing what it's supposed to be doing? Let's do this the lazy way. Yeah, I don't know why that sometimes happens with the comments. It's a little bit annoying. I've had that happen a few times. Oh yeah, even that comment out. Oh, it's really hanging. Let's just put this. This might cause a debug error though. Compile error, because we're never going to get to that rest of that code. No. Still hanging. Okay. Yeah. This I don't think will compile. No, it does. Alright. Fair enough. So basically skipping the nested for loops. I want to see if that's what's causing this to hang. Yeah. That's a shame. Alright, well, let's just draw these for now, make sure we're doing this in the right place. Oh, no. There we go. So we're not getting the debug lines either. Let's just make sure we are actually here. What's going on here? Yeah, why aren't the bloody comments working? Let's just skip that. So part of the problem is it's hanging, and I think it's then skipping the code. At least that's what I'm guessing that error message is. Now it's completely through. And okie dokie. Let's see what's going on here. Let's go to here. And we'll this. Should be. Oh, that's right. Wait, what? Oh, for God's sake. Cross that bridge later. Okay, so number of control points 9, and I equals 1,805. What? What? So that's probably why it's freezing, because it's probably doing an infinite loop. Why is I being 0? Like what? I don't know, yeah. So I equals 0, j equals 0. That's fine. I should skip that. Okay, so this is oh, that's why, I see. Not bad. There. Right, that should stop it from crashing. Yep, so now it's properly moving through. Let's remove that. And we can also, let's get rid of that. It's always something stupid. Yeah, okay, let's delete the breakpoints. Continue. Okay, well that's kind of interesting. So yeah, it's not working. I think probably because the two lines are joined together. Which is why it's always on this point here. So we should probably ignore if the start and end are the same. So let's do effector dist outer line end, inner line start. Yeah, less than that should be rough enough. Still doing it. Okay, let's bump that up. So the lines are being drawn in the right place, which is great. Oh, okay. That looks good. Okay, cool. Okay. So it's kind of working. Cool. And how accurate is that location? It's actually pretty good. I'm pretty happy with that. Let's do. Okay. Cool. Alright, well that seems to be roughly working. So I'm pretty happy with that for now. The thing that's a little bit weird is on the first iteration. Oh no. Oh no, it's working. Okay. Sweet. Okay, cool. Show the splines. So we seem to be successfully detecting when the splines are hitting itself. When it's a separate spline, we're getting the proper intersection there, which is good. So the next challenge, which I'll deal with next time, is with all this info, where these intersections are, we now need to actually split these into individual segments. So for like a segment here, a segment there, a segment there, another segment there. Yeah, that seems to be working pretty well, to be fair. And it's pretty accurate as well. So yeah, happy days. Cool. So yeah, I'll refactor that code a little bit, make it a little bit tidier, then do a bit more research on how I'm going to deal with actually segmenting the different segments or separating them, and then hopefully implement that once I've got that sussed. We can go from there. So yeah, small steps, but just got to keep doing a little chipping away at it. It'll finally get there. This stuff can be quite difficult. Hopefully it'll be worth it in the end. Once we've got like a really complex network system, to be able to do things like have complex road systems and have like a railway going over roads and stuff. Hopefully it'll be worth it. Cool. So yeah, cheers guys. See you next time.